The principal quantum shell are number according to how far they from the nucleus. It means this is the nucleus and how far from the nucleus. Yes, you can you repeat your question? Don't tell us from where to from where this number will come. That's why I said C. Okay. Now you can see from this uh, principal quantum shell. This is the central part is nucleus. Okay, around the nucleus is N1, N2, N3, and N4. These circles represent what? Energy levels. It's clear now? What is the shell? What do you know about the energy levels? And energy level we can also call principal quantum shell. Principal quantum shell. Clear now? Is the next I use this sentence actually. So in your mind there are four: N1, N2, N3, and N4. Any question till now? Okay. Next, principal quantum shell. The lowest energy level is N1. It is close to the nucleus. So where is N1? This first shell that close to the nucleus, and then other N2 and further N2, N3, N4, and so on. Did you get? Now, the electron in energy levels further away from the nucleus have more energy and have less tightly to the nucleus. See the electron present here. Please, electron, look at here. Electron present in first shell, first energy level, so near to the nucleus. Is tightly hold because like a two magnet, you have two magnets. So if closer to each other, there is more attraction. But if little away from each other, there is no attraction, is it? Or you can say now forces are weak because they cannot hold it for long time. It will break down. So that's why the written there, the electron in energy level further away from the nucleus have more energy and have less tightly by the nucleus. It means nucleus, the attraction between nucleus and the outer shell is very weak. If attraction very weak, we can remove electron easily. Is it? Because this is very near and this is little away. If you have more shell, this electron will be here. If you have more shell, this electron further away from the nucleus. If away from the nucleus, forces are very weak, we can remove electron easily. Now, third one, electron do not move in a fixed circular path. They occupy a space called the atomic orbitals. Now, today you will get what is orbitals. What is orbitals? Because these terms we will use. That's why I'm going to write these all down. Orbitals. Can you read number 5, please? What is orbitals? Atomic orbital. You can see this one. Go back little. See this one? This is the first shell. Is it? The first circle. Between first circle and second circle, is there gap between this one? This is the space. Yeah. Okay. Then number 3 and 4. This is this gap in between. Yeah. There is a circle. Yes. Between these two circles, there is a gap. You are agree? I show you in history of an atom. There is Rutherford did an experiment. You know, some they pass directly rays, some bends towards negative and positive, and one ray it hit and returned back. That we discover nucleus. Okay? So when hit and return back, it means there is a space. And in space something present there, that's why that rays is returned back. In the last class we studied. Okay? And that space is actually known as orbitals. And here in between the circle, there is a space, this one. and between first and second circle this space, between nucleus and this circle this one is a space. These kinds of space what we call occupy space called the atomic orbitals. Atomic orbitals. Now we divide subshell into orbitals. We divide subshell into orbitals. See, this we divided energy level are same. When shell divided, we got subshell 4, 4, 4, 4. Now we are going to divide S, P, D, and F into more subcategories because we are going to learn for electronic configuration. So we must first build up what? A rule. Then we can draw electronic configuration. Understand? So for making a rule, we need to understand what is behind it. Did you get now? So for this, when we divide subshell, we got orbitals. We got orbitals. I will show you then I will write. I have to explain again where is Ahmad till now. The total number of electron, Ayub, your answer of your question, the total number of electron that can occupy any principal shell, mean any number, even K, L, M, and N. Understand? R, N to 1 to N4, where it is 2n square. This is the formula, 2n square. You can use this formula here. 2n square. What is n here? This is the rule actually. N1, N2, N3, N4. Did you get now? If value of n given to you, I said n1, how many electrons are there? 2. How you will calculate 2 into 1 taking square is equal to 2. If I said n2, how many electrons are there? 2 into 2 square is equal to 8. If I said n3, how many electrons are there? 2 into 3 square. What? First one is wrong? If you're taking square of 1 then? Okay, no problem. Here 3 square is equal to 18. And if value of n is equal to 4, did you get that? How you got this number? By the formula of 2n square. This is a one scientist of Fock. His name is the Fock principle we call. He said that by using this rule, we know how to fill up electron in any shell, in any energy levels. How to fill up electron in any shell, in any energy levels. Clear till now? Yeah. Any problem? Now, read, this is information for you. This is information for you. Read from there. This one information. Did you get what is quantum subshell? Quantum subshell, apart from the first, are split up into subshells. Each principal quantum shell contain a different number of subshells. The first energy level contains one subshell. The second energy level contains two subshells. And third energy level contains three subshells. Fourth energy level contains four subshells, like that. Okay. Now, because this is going to this side. Okay. Come on here. This question I will give you in your multiple choice question. Keep in mind. The subshells are distinguished by a letter S, P, D, and F. We're distinguished by a letter S, P, D, and F. Understand? Yes. And the energies of electron in the subshell increase in order. This order will come. You need to memorize. Which one having the highest energy? Which one is F? See the sign. Understand? S is less than P, P is less than D, and D is less than F. This is the order. Don't forget, please. This order, maybe I will change. Look at there. If I change F, I bring here in the place of S, and S I will put on the outside. It's incorrect, is it? If I bring D in first and S, or I put S in the second one, P I can replace the last one. This is also wrong option. So you will check in multiple choice question A, B, C, and D. Where is this correct answer? S, P, D, and F. Maybe I will put the order same. S, P, D, and F. Is it? Is their order? But I will change the sign. Do you understand? Yeah. So this is wrong also. The place is same as PDF. I did not change the letter, but I changed the sign of the. So you need to memorize this. Any question till now, till section? Step by step, because these things you need to learn in grade 12 again. So if you are perfect now, grade 12 just revise and go fast. This is the summary. Principal quantum shell are energy levels written in a one column first column. Is it? This is the summary what we study. See K, L, M, and N. If K, what is the principal quantum shell? N1, N2, N3, N4. Did you get now? Okay. Second, maximum electrons they can get 2, 8, 18, and 32. How we know? You got from the book. Number of subshell. If N1, how many subshell there? 1. If N2, how many subshell? N and 3, this you studied before and I told you. This number 2. Read it again. This number 2. One. Yes. So now compare this one with your that tables. How many total students in your class? 9. Absent? 1. Yes. I don't know. It's will online. No participant. If you will come, then I can. Huh? Huh? Okay. Okay, send this. Because I'm waiting for him, that's why I'm going slow. Maybe internet problem or internet problem. And those they have no idea how they will join. Okay, you will help him. This is finished, Abdullah. You read this one. The first energy levels contains 1, second 2, third 3, and fourth 4. This you will get here. Here. Energy level N1 subshell 1, N2 2, N3 3, N4 4. Understand this column also? Okay, now the last column actually. Last column here about the subshell. Let him, I will repeat for him a little bit. First
Good
thing
morning.
We study shell. Please concentrate, Hamid. We study shell or principal quantum number. Shall mean K, L, M, and N. Principal quantum number mean N1 or energy levels. We can call also energy levels. The circle around the nucleus we call energy levels. So N1, N2, N3, and N4. So first I am going to play again these slides. Please read and then I will continue with your colleagues. This we will study now today. This is our objective first. The number and relative energies. Number we know that atomic number and mass number. Atomic number of proton. Mass number proton plus neutron. And energies of S, P, and D. You saw that order. This order. Which one having the lowest energy? S. Then P. Then B. Then. So don't forget this one. And for the principal quantum 1, 2, 3. And also 4s and 4p. This I will explain you when we build up the order. 4s and 4p. So these two are left. Others we finished. Now what is principal quantum number? Electrons are arranged outside the nucleus in energy level or principal quantum shell. We represent by n. The principal quantum shell are numbered according to how far, mean near to the nucleus or away from the nucleus. See this first shell, N1, second N2, third N3, and fourth. These circle are represent energy levels. So energy levels or principal quantum numbers are same. The principal quantum shell. What is this? The lowest energy level N1, then N2, 3, 4, you got the information. So second, the fourth point is the energy levels further away from the nucleus. If near to the nucleus, they hold tightly. Away from the nucleus, the forces are very weak. So we can remove electron very easy. You can see this one. If near to the nucleus, any electron like this, blue, green, or yellow, or red, if near to the nucleus, difficult to remove. But away from the nucleus, the forces are weak. We can remove easily. We can remove easily. Now we need to understand what is orbitals. The space around occupy this diagram, this space between first shell and second shell. This white color, this space, and this one also space. These spaces are known as atomic orbital. Point number 5, electrons do not move in fixed circular path. They occupy a space called atomic orbital. So what is atomic orbital? The space between the shells. We call atomic orbitals. Then how we know that we have 2, 8, and 18 electron? By using this formula 2n square. This 2n square, if n is equal to 1, you get 2 electron. If n is equal to 2, it will become 8. If n is equal to 3, 18. If n is equal to 4, 32. Just replace n, this n, by the number given to you. Maybe 1, 2, 3, 4. Now, what is principal quantum shell or quantum subshell? It means we divide again N1, N2, N3, and N4. We divide it again into subshell and orbitals. Orbitals, I am going to explain you, but first you need to focus here that what is the difference between their energies. S having the less energy. Concentrate having here. This order will come in multiple choice question. S having less energy than P, P is less than D, D is less than F. This is the order of energies, how to fill up electron. Because we have 4 subshell S, P, D, and F. And in these subshell, we must know what is the energy of each subshell. Which one having lowest energy and which one having more energy as compared to other. So we need this other order specially to memorize. Now, after that, this is the summary of what we discuss. Principal quantum shell or shells, or you can say energy levels. These different terms we will use, but the meaning are same. If you call principal quantum shell, it's mean N1, 2, 3, and 4. If you call shells, it means K, L, M, and N. If you call energy levels, it means same and 1, 2, 3, and 4. How many electrons you saw before? 2, 8, 18, and 32 by using the formula 2n square. We can get these numbers. Now, if n1, how many subshell more? 1. It's similar like a subshell, like energy levels 1, 2, 3, 4. Now, concentrate on the last column. This one, number of subshells. It's mean now we divide or we arrange. You can say we arrange these subshell in an order. We are going to build up an order. Okay, and how to build up an order? You know, if n1, how many subshells there? One, only one. That is our first, what we call S. That is our first, what we call S. S represents subshell. What do you know about n1? Sorry, one means energy level. One means this energy level. If n1 and subshell is S, we write 1s. 1 means the shell where electron present, the energy level where electron present, the principal quantum shell where electron present. So 1, 2, 3, 4, these 1, 2, 3, 4, you can say 1, 2, 3, 4, these are represent one principal shell, or you can say energy level. Understand now? And S, P, D, and F represent what? Subshell. Understand? So now correlate between both. Just need your concentration. If you get, it's very easy for you the next topic, electronic configuration. If N1, how many subshells there? 1. Good. That's why we write 1s. Okay, come on in second row. If N2, 2 subshells, S and P. That's why we write here 2s, 2p. So 2 represent which energy level is there. Understand? S and P are subshells. If n is equal to 3, come on in third this one. If n is equal to 3, so it means 3 subshells. First 3, S, P, and D. That's why we write 3s, 3p, 3d. And if n is equal to 4, so how many subshells? 4 subshells. So 4s, 4p, 4d, and 4f. Just before this, we will put the numbers. How we know these numbers? Before s, we wrote 1, we wrote 2, we wrote 3, and we wrote 4. How we know? From energy levels. From value of n. From value of n. See here n1, there is 1. Here n2, 2. Third row, n3. So that's why we write 3s, 3p, 3d. Here n4. That's why we write 4s, 4p, 4d, and 4f. Clear now this one? And this last column actually we are going to arrange in a order. These all section we are going to arrange in a order for what? For electronic configuration. So please just call with me. First, what is the section? Huh? 1s. Second, 2s. Good. Then 2p. Good. After that, 3s, 3p, 3d. Excellent. And then 4s, 4p, and so on. Till 4p we stay in grade. Till 4p. Did you understand how to do? Now, which will come first? 1s. Just focus here. This is our order. Which one come first? 1s. Then 2s. Then 2p. Then 3s. 3p. 3D, 4s. Maximum electronic configuration will finish till 4s. But 4p we need to study because in our objective, I told you I will explain later. 4s and 4p. Understand? So I will explain now what is the difference between these 4s and 4p. Okay, that 4d and 4f neglect, no need. Till 4s maximum. But this I wrote only to explain you what is the difference between 4s and 4p. Which one having lowest energy, which one having highest energy. That's it. So 4s having less energy as compared to 4p. That's it. This is your answer. If the comparison question between 4s and 4p, so what is your answer here? S having less energy as compared to P. That's why we write 4s first, then 4. Any question till now? Similar situation here, but here we are going to build up the order. This red arrow, it means energies of orbitals, of subshells. So when we travel from this point to this point, what will happen? Energies increase. Energy increase. This sign is going upward, it means energy increase. Now, N1, 2, 3, and 4. What do we call these? No, N1, N2, N3, and N4. Principal quantum shell are, or what we call energy levels. Mostly focus on these two words. Okay, energy level or principal quantum shell. Understand now? Now see some lines are going out from these shells. Similar thing, but you need from N1 only one line there, is it? There is only one line. It means we have only one orbital, that is 1s. From N2 we have two lines. What do you mean by these two lines? Between two subshells, 2s and 2p. N3, three subshell, green line. Focus on green line. 1, 2, and this third one. Forget it for a few seconds. This blue one. This I will explain. But let's see first from green point N3. N3, how many lines? 3 lines. 3s, 3p, and 3d. It's clear now? Why 3s, 3p, and 3d? Because energy level is third one there. That's it. Now N4. It's mean how many energy, how many subshells there? 4. So we will start from S, 4s, 4p, 4d, and 4f. Understand? Same like I'm going to explain that one. Same like previous table we saw. Yes. Just a 1 minute, then you will go. See, they wrote where 4s before 3d. Is it 4s before 3d? Because this from energy level, fourth energy level, this 4s entering here. Because excellent, you can go on. Because this point I want to explain. Because 4s having less energy as compared to 3d. Why they wrote 4s first? This is your question, Sham. You also your question. Why this 4s? Why they wrote 4s first as compared to 3d? Because 4s having less energy as compared to 3d. Now compare 4s and 4p. More energy as compared to 4s. So 4s we will write first, then what we will write, then 4p. So if there is a question, the comparison between 4s and 4p, are you able to write the answer? Yeah. Okay. If comparison between, yes, but this only just showing the energies, because we want to write the answer. And grade 12, they study now this one. Why we write 4s and 3d? In grade 12, we will switch these two. We write 4s after 3d. So that one you need to understand that why we wrote. Look at here. In sequence, we write first 3d, then 4s. But the order you saw, which one is? This is less energy, then this, and then this one. Did you understand? Yeah. So it means first we fill up the lower energy, then higher energy. Understand now? First lower energy, then higher energy. Why they wrote here 3D first and then 4s? Actually 4s having less than 3D. Is it? So 4s must be written before 3D. That point I am going to explain. 4s must be written before 3D. Why? Because 4s having less energy as compared to 3D.
Why didn't they do it with the number? Like 2, 3, 3
Yeah. No. P and S energies are okay about the P and S because it's depend upon the orbitals. But when you have D subshell, there is more subshell, more crowded. So more electrons there. With more electrons, force of attraction is greater. If force of attraction is higher, then what will happen? We need more energy, is it? So when we go away, that's why they gave the question only about 4s, 4p, or 3d or 4s. They did not compare S and P. Because in P, how many orbitals? And in D, how many orbitals? In F, how many orbitals? 7. So when we what over the energy of F, the highest as compared to D, P, and S. Understand now, sir? That's why they built up this order. So there here two questions. Why 4s written before 3D? What is your answer? Less energy. That's it. Why 4s written before 4p? Less energy. If I just switch this question, what is the difference between 4p and 4s atomic orbitals? No, my question about 4s and 4p. What is the difference in energy levels? Or you can say what is the difference between energies of 4s and 4p orbitals? You can explain with the reference of P or you can explain with the reference of S. When you use S, lowest energy. When you want to explain with the reference of P, then more energy. Did you understand now? Yeah, close, no problem. Close. Okay, what is atomic orbitals if you are going to explain this atomic orbitals? Okay, atomic orbitals is the region of space around the nucleus where probability we are going to finding of electron, that the percentage of electron were present in first shell, second and third. So we call atomic orbitals, mean the space between two shells. I circle before 2 times. The subshells are split further into orbitals where the electron are placed. Number 2, subshells are split, mean it's divided, breakdown further into orbitals. Subshell again divided into further into orbitals. Understand now? So how many orbitals you can see? S, how many orbitals, atomic orbitals? 1. That is only S. 1. P, how many? 3. So P having 3. Px, good. Py and P. Understand now how many P orbitals? Any problem? Now D how many? 5. You just need a number that how many for D. But P you must know Px, Py and Pz. Did your syllabus? Here. D how many?
D5.
5. F 7. No need that explanation of D, that dxy, dyz, dxz, dx square, y square, and dz square. Total it will become 5. So no need to memorize these, is it? But you must know about px, py, and pz.
From where did they get DXY and DY?
When they divide D subshell, when they divide this D, they got more atomic orbitals. When subshell previous, can you please focus on this one? Number 2,
Yes, they split.
they split further into orbitals. They split up further according to their capacity, according to their tendency to accommodate electron or release electron. So, like we divided shell into subshell. How we divide that? K into S, L into P, and like that. So when we divide shell, we call subshell. When we divide subshell, we call orbitals. So orbitals, we have 4 subshells. So how many orbitals for each? 1, 3, 5, and 7. 1 for S, 3 for P, 5 for D, F for 7. Understand now? So you need only the number here, 5. D how many? 5. And in grade 12 you will study that dxy, dyz, dxz, and dx square, dy square, and dz square. The shape will come in your exam. You need to draw the shape of S and P. You need to draw the shape of S and P. This is one objective, number 2 in your syllabus, and this will come in your short test. Draw the shape of S orbital and P orbital. Now open page number 31 from your chemistry book. Page number 31. On the top, given there these 3 figures. The first one, the green big blue circle is S. So what is the shape of S orbitals? Circle, spherical. Now go further for 2p. First one is 2p z, second one 2p y, third one 2p x. So you must know how to draw these shape, please. Page number 31 from your chemistry book. The first one, figure number 2.19. Figure number 2.19a. A for S orbital. Then B. The 3 2p orbitals. 3 2p orbitals mean px, py, and pz. Why they write 2p, 2pz, 2p? Why? Because it's second orbitals. This one, 2p. In order 2p. Understand? So you must know, please, how to draw the shapes of atomic orbitals of S and P. S and P. Any problem? See, now here something is there. Atomic orbitals are degenerate orbitals. Degenerate means they have their own energies. All are not similar. So orbitals having the same energies are called degenerate orbitals. For example, px, py, and pz. Now solve your question that how they divided these 3. If they have similar energies, they divide like px, py, and pz. Point number 4, please read it. This is your concept, and maybe the reason will come.
Orbitals having the same energy are called
degenerate
orbitals.
Uh,
For example,
good.
px, py, and pz.
Yes.
Are degenerate orbitals.
Good. Now, nth is a principal quantum number, you know, n square. There are n subshells, n square orbitals, and a maximum of 2n square. This we used before this formula. This is all about today for shell, subshell, energy levels, atomic orbitals, and the orbitals also and we built up order how to fill up an electron. How to fill up electron. Understand now?
Yes.
Now, because for him time is over.